I'm creating this video because I know that you are worried about, the situation that you're going through. I don't want you to miss the instruction. And even though I have a lot of videos posted on my YouTube channel, I'm doing this because this is specifically for physical science. Okay? So, what you're gonna learn after watching this video is how to write and name ionic compounds that are made of representative metals and monoatomic or polyatomic ions. Monoatomic, only one non-metal. Polyatomic, then you're gonna have more than one non-metal involved in that ionic bonding. Lewis structure. As you can see, there are 4 types of ionic compounds. The first type of ionic compound that we discussed in class was the one that is made of a representative metal and a monatomic ion. Representative metals are the metals that are located in group 1, 2, and 13. Monoatomic ions means mono means one. Means that you're going to have only one non-metal. As you well know, an ionic compound is made of a metal plus a non-metal. So the first type, the metal is going to be a representative one. You have that in group 1, 2, or 13. And then you have monoatomic ions, only one non-metal involved. Okay? You already know about that type. One example is, okay, let me look over here. One example. I'm gonna look at calcium and, let me see, nitrogen. Remember that calcium is in group 2. I have 2 valence electrons plus nitrogen is in group 15. I'm going to cover the 1. I have 5 valence electrons. 1, 2, 3, 4, 5. Then I'm going to draw my Lewis structure. Calcium is a metal, always positive. 1 and 2, I put it 2 over here. Nitrogen is a non-metal, okay, always negative. And then you're gonna count over here how many are needed for A, 3 more, and you put a 3. When you're writing the chemical formula for this ionic compound, you know that you have to dance, baby, dance. So your chemical formula is gonna be Ca3N2, because you are switching that, okay? This is the cation, cation. This is the anion or the negative ion, okay? How are you gonna name this? Easy piece of cake. The cation never change the name, so it's gonna be calcium. The anion, which is the nitrogen, you are gonna drop the ending of the element's name, and then you're gonna add IDE. You already learned about that. The first type of ionic compound. Now the second type of ionic compound that we have. Second type. Representative. Okay. We're going to continue with representative metal. Representative metal. And polyatomic ions. Polyatomic ions. Representative metals, they are located, see, as I was telling you before, group 1, 2, and 13. Polyatomic ions, where are you going to find the polyatomic? Okay, so for the second type, we have the representative metals and polyatomic ions. Representative metals, that are the metals that are located in group 1, 2, or 13, and the polyatomic ions, you're going to find the polyatomic ions on the back of the periodic table. The periodic table. Periodic table. Now, I'm talking about the periodic table that I used to pass when you were in my class. You don't have the periodic table, so I'm gonna send you that periodic table. You're gonna print that, you're gonna laminate that, and you're gonna bring that to class every single day. Because if you look on the back, you have a list of polyatomic ions. You have cations that are polyatomic ions, but we're not gonna touch them. And then you have anions that are polyatomic ions. For example, let's say that you have an ionic compound that is made of representative metal, aluminum. Let me pick aluminum. And then I'm gonna look at the polyatomic ion on the back of the periodic table. Let's say that I'm gonna look at sulfate. Sulfate. This is what I want you to do on the classwork. Aluminum is in group 3. No, group 13. You cover the 1. 3 is left, meaning that you have 3 valence electrons. If you look at the back of the periodic table, sulfate is SO4, and on top you have the -2. That -2 is the oxidation number. If that oxidation number means that this polyatomic ion has only 2 electrons that are ready for bonding. It's more complicated than that, but then when you learn about covalent bonding, you will see why these 2 electrons are available for bonding. The Lewis structure, okay, the same. Open, you group in sign. Aluminum is the metal, always positive. 1, 2, 3, positive 3. The sulfate, you don't have to guess that. Remember, that is a given. They are giving you that information on that table. So you have SO4, and then you have the -2. Once that you have the symbols and the oxidation number, in order to write the formula, you're gonna dance, baby, dance. So you have Al2, and since the oxidation number of the metal is bigger than 1, you have to open parentheses. SO4, you're gonna close the parentheses, and then you're gonna put a 3. Why are you gonna put a 3? Because it means that for 2 cations of aluminum, you're gonna need 3 polyatomic ions. Ms. Ramos, how are we gonna name this ionic compound? Easy piece of cake. What happened? The cation never ever changed the name. So I'm gonna leave aluminum. And the polyatomic ion already have a name, so I'm not stealing that for here. Sulfate. And you are done naming and writing chemical formula for the second type. Now, for the third and the fourth type, we are not going to touch that in class. Those are the ionic compounds that are made of transition metals and monopolyatomic ions. Now, what happened with the transition metals? That the transition metals, they can have more than 1 oxidation number. When you're writing the name, you have to write that oxidation number using Roman numbers. But we're not doing this. We are not going to be naming ionic compounds that are made of transition metals. So we are going to stick to group 1 or the group 1 and the group 2. Representative metals and monatomic ions, and representative metals and polyatomic ions. Cation. So let's say that I'm giving you the name. I'm giving you the name of a compound. You know that is the name of the compound because usually you're going to have 2 names. When we're talking about elements, you're going to have 1 name. Rubidium, cesium, fluorine, carbon. But when you have 2 names in there involved, you already know that it's a compound. Your first step, this is important because then you're going to learn about covalent compound. You're going to look at the first one, and then you're going to ask yourself, is this element a metal? If the answer is yes, then you have an ionic compound. You have an ionic compound. There's no other way. You have an ionic compound. You are gonna look for the symbol for sodium. You need to look at the periodic table. There's no other way. So I have Na, and then you know that sodium is located in group 1, and that sodium is an alkali metal. The oxidation number of the metal is always positive. Group 1 plus 1. Then you're gonna look at the second word. If the ending is IDE, oh my God, I have a monoatomic ion. If I have a monoatomic ion, that means that sulfide comes from sulfur. And sulfur has a symbol. It's an S, and is located in group 16. 16, 6 valence electron. 2 more, okay? 2 more to reach A. And if you don't know how to do that, you write the symbol 1, 2, 3, 4, 5, 6. And then it's a non-metal. It's gonna need 2 more to get the A. It's a negative because it's a non-metal, 2. Once that you have the symbols and you have the oxidation number, how are you going to write the chemical formula? Easy piece, okay. You dance, baby, you dance. Just like that, okay? Chemical formula. Now, let's say that you have sodium phosphate. You're going to do the same. I have a metal, my symbol, my oxidation number. But then I'm going to look at the second word. 8. If the ending is 8 or 8. Oh, polyatomic ion. This is a polyatomic ion. You need the list that is on the back of the periodic table. And then you're going to look for the formula. Phosphate is PO4 with the -3. You're going to put over here PO4, -3. Once that you have the symbols and the oxidation numbers, what do you do to write the formula? You dance, baby, you dance. Miss Ramos, you didn't open a parenthesis over here. I know. Look at the oxidation number. It's 1. Do you have to open the parenthesis and put a 1? The answer is no. You don't need to do that. Okay? Why not? Because for 3 cations, you need only 1 polyatomic ion. When do you have to open parentheses? When the oxidation number of the metal is bigger than 1. In your case, it's going to be 2 or 3. No more than that.